Right, hi everyone, welcome back. I hope you're suitably caffeinated. So yeah, I'm Mike. I'm a data scientist at a company called Dendra Systems. I've dropped in the few shot learning buzzword in here with the aim that that's what I'll get to by the end of the talk. But I'm also very, very thankful to Stephen's early session today talking about putting tools in the hands of experts, because that's very much one of the takeaways that I wanted to get across in my talk of what we're doing with our ecological restoration processes. So first of all, to intro Dendra Systems a bit with a bit of a case study. We are an environmental monitoring, restoration and general land management company. So we have teams of ecologists and we do active seeding using a fleet of aerial UAV seeders, and also a fleet of monitoring drones equipped with multispectral RGB and LiDAR payload. So that's kind of the core of our aim, is to scale up the amount of area that we can restore by shifting everything over to UAV-based seeding and monitoring. So in that case, we've worked with a lot of governmental, NGO and industry clients across the process. So we go right from the initial baseline surveys and site selections, both the actual seeding areas and control areas, to get a baseline for identifying where are the regions that are actually likely to benefit most from reseeding. Then we actually can carry out the reseeding campaigns, initially do a monitor for seeding success, and then that switches over into a longer term monitoring process where we use both field ecologists and remote sensing jointly to keep an eye on how the regrowth is going, whether any further interventions are needed. And this is not just about regreening, it's not just about putting a certain amount of green cover on the area that we're seeding, but it's actually how can we use the tools at our disposal to make sure that we're actually regenerating stable native ecosystems that are healthy and aren't going to just be monoculture or worse, introducing invasive into the environment. So as part of a case study, one of the big projects we've got at the moment is mangrove seeding. So that starts off with satellite-based land cover models. In this case, it's VHR, 30 centimetre resolution type products, where we do mangrove extent and salt marsh mapping to figure out, where is the current mangrove cover, where is it degraded, and during that site selection process we also do sub-centimetre RGB imagery monitoring that is actually sufficient to detect early stage mangrove seedlings, so we can monitor with a quick turnaround the regrowth cycle. And as I mentioned, that's all combined with field studies to make sure that we're actually properly ground truthing our EO results and providing literally the boots on the ground confirmation, both for training our models and for evaluating the results as we go out to different clients. So that's definitely a core part of our work, is making sure we've got that expertise in the loop for each and every project, and we're validating everything. So this is an example of one of the reseeding cases where we've got a before and after. We're using such high RGB resolution for our products, sort of accelerate the post-seeding analysis to look at these very small mangrove saplings just as they're why is that video not? As they're emerging, and they're at that sort of 9-month stage of growth where you can see the first major leaves emerging, which is what you need to be able to actually distinguish them from imagery. So by having these monitoring capabilities, we're able to quickly, in restoration terms, get the metrics for our seeding success, identify regions that aren't necessarily faring as well, and what we can do about that. It's a core tool, and we're scaling this out at site using ML-based sapling detection counters. We can get these density maps for where the seeds have taken early on. After we've done a baseline for seeding success, we move into the longer term monitoring, and we have, as I say, most things are based on UAV or aerial surveys. So products are 5 centimetre multispectral and LiDAR based spectral index and elevation type elevation map products. But the real sort of extra mile is in terms of doing species identification both for flora and fauna, so we get a complete picture of how the ecosystem is recovering, and also assessing the human impacts, so we can stage if there's any necessary interventions. Yeah, so on the subject of this flora species identification, that's sort of the what I want to focus on for the shifting a bit more into the deep learning side of the talk. I would say it's the most interesting problem that we tackle in Dendra, and by that I mean the most challenging, because I'm calling it a long tail problem here. I'd probably call it mostly tail, because we can't anticipate up front for any given project really what are going to be the species that are important to the client, and developing monolithic models, even if we restrict ourselves to a specific region, is extremely challenging. And even once we've gone to the process of, with the client selecting, these are the key species we're going to focus on monitoring, that's where the long tail really kicks in, and we've got either convergence of appearance between similar, whether related or not, species, making the distinction process, even at sub-centimetre resolution, hard because the observables just aren't there, or you have morphological variations due to climate, growth cycle stage, other stressors that mean that the species you're trying to monitor can have a huge range of morphologies which overlaps with other species in the environment that you're trying to monitor. So all of this wrapped together is we need a flexible way of building up a backlog, a corpus of knowledge, and being able to respond quickly to new projects where we don't have models specifically trained end-to-end for certain species profiles. The case study that I'm sharing here is from a customer in the Middle East that was actually very interested in detailed species level profiling of their arid forests. So in this case, they wanted a very detailed breakdown of all the species they had present. We hadn't previously worked in the Middle East, so we didn't have any models or any UHR sub-centimetre imagery in this region. So we made use of existing work with clients that we'd already trained a self-supervised foundation model on our UHR data in Australia. And so basically treated this as a transfer learning exercise where can we use our similar arid environment, but one in which the fine-grained information of these species are not present because none of these are native to Australia, reached as far as I'm aware. Disclaimer, I'm not an ecologist, so apologies to any ecologists in the room for anything I may get wrong on that side. But yeah, the main outcome of this project is that we were successfully able to, without doing any retraining of the foundation model or adaptation to the new domain, able to generate workable levels of classification accuracy at the species, and in some cases even it's a bit tentative, but that bottom one is also at the subspecies level for certain acacias, which from the images here, I mean, certainly I'm not able to tell the top two apart, which are two of the species that we're able to get 70-odd% F1 score on the classification. And this is across 30-odd forests. I can't remember the total area, but yeah, we're talking about sort of a dedicated project to develop this model based off the corpus that we've been working on in other areas of the globe. So, but we can take this to the extreme in terms of, here we were working with average of a few thousand samples per species, so it's more of a conventional modelling task. But if we want to really, and this is where we get into the few shot learning, put very lightweight classifiers on this and aggressively productionize this so that we can turn this into an interactive tool. So this is just an example of detecting rubber bush, which is a very invasive species in Australia that a lot of the clients we work with they're obligated to control as part of the restoration process. And this is a simple classifier that's being trained in a couple of different iterations to converge on the actual imagery tiles here that contain rubber bush. So the feasibility of doing this depends entirely upon how rich your foundation model or your encoders embeddings are, because it's deliberately, by going to the few shot domain, you're limiting how complex you can make the downstream model, but that does make it extremely responsive to the specific few shot labels that you give it. So here in the case of 2 or 3 training iterations, this is real time, I haven't sped the video up, but yeah, in the space of less than a minute, you can get for a specific site the locations of where all of this invasive species are located, and that can then be fed in either using our this would, in the first instance, go to our ecology teams to understand where the areas we might want to focus are, or what recommendations we might want to make to the client. But these are also tools that could be exposed directly for exploration of the data and provide better understanding to the client of what's located in a flexible way. So yeah, this is taking things from a modeling approach to more of a semantic search tool, but for species-based ecology. So yeah, that's I think that's more or less time. So yeah, my takeaway from this was just to show you a bit of what we're doing at Dendra and how we're tackling what is effectively an extremely challenging and we need to be flexible in terms of providing these kind of on-demand species identification products. But yeah, as Stephen was saying a lot, the way forward with this, when you rely on the experts, I wouldn't be able to do any of these tasks because I'm not an ecologist. We're entirely reliant on our ecology teams to drive the actual species identification. But if we can put more responsive tools in their hands, we can scale this up to larger areas and make the restoration process more effective and ultimately more generalizable. So yeah, I think I'll leave it there. Thanks everyone.
We do have time for a couple of questions. We got any questions in the room? Well, I can ask one for a start. So I'm curious, who are the people that are paying for this essentially? Because I know we hear so much about deforestation to make space for agriculture and so on, but this is essentially the opposite, it sounds like. Yeah, so where does the money come from for that?
Yeah, it's a mix of ones. In Australia, a lot of it is mining, like ex-mining sites, so they have legal obligations over there to meet certain closure criteria. Yeah. So there's a whole environment developing around being able to support and demonstrate that they've met the governmental requirements for being able to close that model. So that's one area. It is very much piecemeal. A lot of it is governmental targets can directly. We've got projects available for doing this, so it's a bid-based system. But yeah, it varies is the answer. But yeah, it's
I'm glad it's happening. Yes.
Thank you so much for your presentation. I didn't quite get on terms of saplings how you separate the acacia, the Vachelia nilotica, when they're still exactly. How do you separate them? Like they're very, very similar.
It's a good question, and I'm amazed that we can. Yeah, I'm entirely reliant on our ecologists for doing these kind of distinctions. So yeah, it might well be like when you get down to the very high resolution, there may be some distinguishing features, whether it's about the leaf shape or orientation or branching. Like this is me talking in general rather than for this specific species. But yeah, other sort of routes around. This is a barrier that we are pushing up against because we're driven by client requirements. But determining even with this highest resolution UHR data, there are going to be cases that we can't distinguish, so we have to be able to probe and draw that line of, okay, this is something that we can quickly say, we can classify it with this accuracy, is this useful to you, or, this needs to be boots on the ground field ecology only because the distinguishing factors are just not visible from the air.
I think we've got time for one more, yeah.
On the management side, do you integrate some sort of AI in that too, or is it primarily the monitoring?
Sorry, could you say that again?
So, for example, if the ecologist then on the ground and actually, or not just the ecologist, but the clients doing stuff on the ground, do you give them purely a list of potential, essentially a map of where things are, or do you also recommend any kind of decision making to actually control the problem?
We generally speaking, it's a dialogue. So we're recommending that these are the areas that are, suffering from invasive species, and therefore it needs some action. So some of those cases we may be more involved in the actual treatment process, but mostly it's based on mapping products and leaving the decision making to
integrating ecological models, for example, how invasive species might spread, and
not directly. We're on the monitoring rather than the prediction side, but that is it's definitely an interesting direction that I've been picking up from this conference, that there's a lot more that we could be doing in that regard.
All right, let's thank Michael again.